Okay, so today's plan is to correct over the assignment that you got yesterday on ratios and proportions. They were applications of proportions predominantly. And then we'll go through and do a review activity. What I'm going to do on here is go through the problems from the review activity so that you have something to look at and explanations on how to do them as you're studying tonight for tomorrow's test. Again, everything on the benchmark is listed here. The stuff in the top portion is what you have to be able to do to pass the benchmark. The stuff on the bottom portion is the stuff that will show up in the advanced portions. The answers for what was due today are right here. If you're having problems with any of them, come in and get some help. The problems themselves you can find in your book as well. And then the activity that you did in class today where one person was talking through the steps while the other person was writing them. I will go through and show how to do each and every of those problems right now. So the very first one here says to simplify. And as we're simplifying something like this, we need to remember order of operations. Please excuse my dear Aunt Sally. Or parentheses, then exponents. The multiply and divide step goes left to right, as does the add and subtract step. So because we have parentheses here, I'm going to start in there doing 15 minus 4. Every time I take a step, I'm going to make sure that I always rewrite what my problem says at that point so that I don't forget any steps or do anything out of order. After I've done the parentheses, the next step would be the exponent. So 11 squared is 121. I'm also going to do this multiplication because that does not interfere with my exponents over here. So 3 times 4 is 12. And now all I have left is the adding of 121 and 12, and that'll get me 133. So the answer to number 1 is 133. Number 2 says to distribute, and so this group here in the parentheses all needs to be multiplied by -4. So the first part is taking -4 times 4, which would get me -16. And then the -4 times the minus x makes a positive 4x. Typically when we write these, we'll write the x term first and then the constant. So you could write your answer like I have over here. But if you left it in this order with the negative in front of the 16 and it coming first, that would be fine as well. Okay, our next 3 problems are all percentage problems. If you want to use the proportion method, you can. Remember that if you're using the proportion method, it's percent over 100 equals the part over the whole. And if you're having a hard time figuring out what is the part and what is the whole is the one that you're taking the percent of. So it says of 230, of 7, of what number? That's your whole that we're referring to. The one that has the percent sign on it obviously is the percent, and this one we don't know what percent. And then the other number, in this case what is our unknown, that's the part. 35 is, so here's our part. I'm going to mark it with a P for part. Mark this one with a W for the whole. And right here, 7% of what number is 35, this is your part. So if we're setting up proportions for each of these, you can do it that way. If you're writing it as equations, we take the percent and divide it by 100 first to turn it to its decimal form. Then we multiply that by the whole thing, the one we want the percent of, and that will get us the part we're looking for. So each one of these problems can be set up in either method, and what I'll do is I'll go through and show the setup for each method, and then I'll show the solution that you get either way. Okay, so I tried to save us a little bit of time here. I went through and set each one of these up during a break, so it just kind of jumped on your screen, I'm sure. In each one of these, the proportion method is in green, where I'm taking the percent over 100. Notice here it was 15% out of 100. Here I don't know the percent out of 100, and here it's 7% out of 100. And I set those equal to the part compared to the whole. And remember, the whole is the one that has the word of by it. So of 230, so 230 is the whole, it goes on the bottom. Of 7, so 7 is the whole, it goes on the bottom. Of what number, so the what number, the thing we don't know is the whole, it goes on the bottom. And then what is, that means that the unknown is the part. 35 is, that means that the 35 is the part. Notice it's bigger than 7, that means we're going to have more than 100%. And then finally right here it says 7% of what number is 35, so 35 is the part. If you use the equation method, it's percent over 100 times the whole thing equals the part. Now right here I actually took that percent over 100 and did the division and wrote that piece of the equation as a decimal. Down here I just wrote it as 7 over 100, but I could divide that and write this as 0.07 times x equals 35. Since the number 4 here, we don't know the percentage, I'm leaving that x over 100 to remind me that when I figure out what I get here, that I still have to multiply it by 100 in order to get the actual value of that percent. Now, notice when I went through and solved these, in each one of the proportion methods, I did cross products. If we have two fractions equal to each other, we know that the product we get across the equals will be the same. So the 15 times the 230 gives me 3450, and that has to equal 100 times x. Or here, the 35 times 100 has to equal 7 times x. And right here, 35 times 100 has to equal 7x. Using the equation methods, in this one, I could just actually calculate 0.15 times 230, and I get 34.5. Here, the first thing I did was divided both sides by 7 to get me that x over 100 equaled 5. And then I multiplied both sides by 100 to get that x equaled 500. And finally, in this one, after taking 7 and dividing by 100, then I divided both sides of this equation by the coefficient of x so that I could get x by itself. And I got 35 over 0.07, which gave me 500. Now, you need to be really careful here when giving your answers. In problem number 3 and 5, it just says, what is a percent of this number? Or this percent of what number is 35? So your answer is just a number, and so you'd give it just like this. If we're talking about 35% of $200, then you'd have to make sure you put dollars as a label on your answer. Number 4 would be wrong if you left it as just 500. We're being asked what percent. So you need to make sure that when you answer this question, you're answering it as 500%. Don't answer 5. Don't answer 500. Answer 500%. Okay, moving on. Question number 6 is asking us about a sale price. And there's a couple different ways we can do this. One is to actually calculate the dollars that you'll save. If I do 30% of the whole price, which is $55, this will get for me, because the 30% is what I get off, this will get for me the dollars that I take off of my price, or in other words, the money I save. In order to actually get the answer to this question, I would have to remember then to subtract that from 55, because if I want to know what I pay, I'm going to subtract the amount that I save, which is what I'm calculating here. The more direct way to solve this problem is to say that if you're getting 30% off, what you pay is actually going to be 70% of the original price. So I'm taking, to figure out what I pay, I'm taking 100 and subtracting my saved amount to come up with what I'm paying. And so when I calculate this proportion, I will get directly to the value of what I pay. Notice as I went through with a calculator and did this, I multiplied the 70 by the 55 and got 3850 equals, and then the 100 times x. And when I divided both sides by 100, I got 3850. This is what I pay. If I use the other method here, when I multiplied across the equals, did the cross multiplying, I got 1650 equals 100x. So dividing by 100 gets me $16.50. That needs to be subtracted yet from the $55 to figure out what I pay. And when I subtract that, I will end up with the same dollar amount of $38.50 as the value that I pay. Okay, on to our next question here. It says the student to teacher ratio at a school. So I'm going to write just letters to remind me that students are on top and teachers are on bottom. So 27.5 students for every 1 teacher. And then it tells me that there's 1,120 students in the school. So this ratio is actually the simplified form of this ratio, 1120 students for how many teachers. When this gets divided, I get 27.5 over 1. By solving this proportion, I can figure out the number of faculty members or teachers that are in the school. So again, because it's a proportion, I can determine that 1120 times 1 has to equal 27.5 times x, and dividing both sides by the coefficient of x will get me the value of x, the number of teachers in the school. Now, x actually turns out to be 40.72, and since we can't have a part of a teacher, we're going to round that. And so we'd say there's approximately 41, and we'd use this to say approximately, and we need to make sure we have a label on here, 41 teachers or 41 faculty or 41 staff members, however you want to put that, so that it's referring to the amount of teachers in the school. Okay, our next two problems both deal with similar figures. In order to solve problems with similar figures, we need to make sure that we understand where the proportional parts are. So I'm actually going to jump down to number 9 first. You can see in these two figures that if they are similar, like it says, that the corresponding parts, or the parts that match up, are the 4 with the 14 and the x with the 21. If they are similar, what it means is that any particular side of the first figure, call it side A, compared to that same side in the second figure should be the same if I use a different set of sides. Call it side B in the first compared to side B in the second. And the ratio here of side A in the first to side B in the, or side A in the second, which this ratio simplifies to 2 to 7, that's actually my scale for this figure. Every 2 units over here is going to be equal to 7 units over here. Or another way to think of it is, this figure is 2/7 of this figure's size. So when I set up my proportion now, because over here I had the small figure on the top and the large figure on the bottom, I need to make sure that when I go to this set of sides, I keep that consistent. Small figure on top, large figure on bottom. So I'm going to take and solve this proportion, or I could have used the reduced version of that ratio. And I'm going to go with this one though, because it's more likely what the rest of you have. So I would take 4 times 21, which is 84, and that's going to equal 14 times x. And so again, to solve for x, I divide by that coefficient because I want a coefficient of 1. And when we do this, you'll get that x equals 6. Now, if these were labeled in inches, then I would say that x equals 6 inches. If they were labeled in feet, x would equal 6 feet. Because there's no label on there, the best way to do this is say 6 units. But if you just left this one as 6, since there were no labels here, that would be all right. Problem 8 really is the same kind of problem. We're talking about an object and its shadow. And if we have 2 objects at the same time of day, both casting shadows, it is assumed that these are similar figures because they're both standing at right angles to the ground and the sun is shining on them in the same way. So what we do for this is we take the height of the object compared to the height of the other object, and we can then say that that ratio would be the same as the shadow of this object compared to the shadow of that object. So if we have a 7-foot tall stoplight and its shadow is 5 feet, then we have a tree, which we don't know how tall it is, but we know its shadow is 35 feet. I can say that the height of the stoplight to the height of the tree has to equal the shadow of the stoplight to the shadow of the tree. So I've got the heights on top and the shadows on the bottom, and I have the stoplight coming first and the tree coming second. Now, there's a variety of ways you can set this up as long as you're consistent. You could have put the shadows on the top of both fractions and the heights on the bottom. You could have put the fraction with the tree first and the stoplight second. You could have even said that you're going to put the height of the tree over the height of the stop sign and set that up as equal to the shadow of the tree to the shadow of the stop sign. Notice now what I'm doing is I'm putting the stop sign on the bottom of both fractions and the tree on the top, and having the first fraction stand for height and the second fraction stand for shadow. As long as you are consistent in your setting up, you'll be fine. When you go through and do your cross products and solve for x, you'll find that x equals 49 feet. I didn't actually do cross products. I just noticed that this fraction simplified down to 1 over 7. So for every 1 unit on top, I'm going to have 7 times that on the bottom. So since 7 was on top, I know that I had to have 49 on bottom for this fraction to simplify to the same as that one. And so I would give my answer to this that the tree is 49 feet tall. Now I want to make sure this makes sense. Notice that the stoplight was taller than its shadow, so my tree should be taller than its shadow. But notice that the amount taller, in this case 2 feet, that does not stay consistent. It's not that it's 2 feet taller, it's that it's some multiple taller than the other one. Okay, on the back side now, here we just have a basic proportion. It's a little bit complicated because we've got additions in parts of our fractions, but the concept is the same. What I get multiplying across the equals, 6 times the whole quantity of n minus 3, that should be the same as what I get when I multiply the other way across the equals, or in other words, 2 times the quantity 5n plus 1. The big thing you need to make sure of here is that you've distributed that multiplication. We want this entire denominator to get multiplied by 6, and this entire denominator to get multiplied by 2. Once you've done that, we've got both sides as simplified as they get. Now it's just solving an equation like you've been doing in the past unit. So when I go through and solve this, I'm going to try to get all my variables together on one side by adding or subtracting. In this case, what that leaves me with is negative 18 on the left, and on the right I have 4n plus 2. Now again, once I've got all my variables on one side, then I want all my constants on the other. So I'm going to get rid of the 2 that are on the right and add its opposite to both sides. Negative 18 and negative 2 makes negative 20 equal to 4n. The final step then is to get that coefficient to equal 1, so I divide by the coefficient and get that n equals negative 5. Make sure you check this. When you put negative 5 in for n, 5 times negative 5 is negative 25, plus 1 is negative 24. In the other fraction, I put negative 5 in for n. Negative 5 minus 3 is negative 8, and I get 2 over negative 8. To know if these are the same, I can either simplify the fractions. Notice they both simplify down to negative 1/4, or I can actually divide 2 by negative 8 and 6 by negative 24 and see that the decimals come out the same. So the answer to this problem is that n equals negative 5. Number 11, we're talking about commission now. And commission is a percentage of your sales that you are going to be paid. In this case, 12.75% of everything this salesperson sells, she's going to get added to her paycheck. Notice it says the salary is this much plus the commission. So to figure out her total pay, we're going to start with the guaranteed money of $53,750, and then plus we're going to add the commission dollars. And to figure out the commission, I need to know what is 12.75% of the sales. And it says she sold this much money. So I need to know what is 12.75% of $185,500. Now, just like on the other page, we can do this using a proportion. So I could say 12.75 over 100 equals what out of 185,500, and I could solve the proportion this way, or I could just come and use this equation idea that if I take 12.75%, that means divide it by 100 first to get my decimal, and I want to take that and multiply it by 185,500 and that will get for me that percentage dollar amount that I end up with. In fact, because this finds for me the commission, I can actually write that into this equation. Unlike when I'm using the proportion, I can't actually write a proportion into my equation. So this says, regardless what I sell, because right here is my sales, regardless what I sell, I could replace this with any value, and my equation will tell me her total pay. It's always going to be $53,750 plus 12.75% times whatever the sales amount is. Pulling out the calculator now, you can figure out what this total is going to be. And notice that when I did this, I end up with $23.6 thousand worth of commission. Now that might seem high at first, and you want to question it if it seems odd. But think 10%. To find 10% of something, we simply move the decimal back one. So if we're trying to find 10% of these sales, 10% of that would actually be 108,550. So 18,500 is 10%. You're getting paid 12%. You should be paid more than that amount. So 23,000 isn't that unreasonable, given that 10% is 18,500. Once we found out the commission amount, then we can add that to the guaranteed pay to get a total dollar amount that she'll be paid at the end of the year, and that is going to be $77,401.25. Just a couple more left here. Number 12, it says you earned or worked 1,900 hours at your full-time job and 550 hours at your part-time job. This statement here tells us what we need to do. It says what percent of your total hours. So that means your total hours is the whole amount we're trying to compare out of. And we want to know what percent are from your full-time job. So this is the part that we're looking for. So when we think about it in terms of the ratio or the proportion here, we want to know what percent is the same as my part, which is my full-time job, which is 1,900 hours, compared to my whole. And my whole, notice, is total hours, which is neither one of these numbers by themselves. It's the sum of these two. It's what I did at my full-time job plus what I did at my part-time job. And so that total here is going to be 2450. This fraction represents the percent, or will help me find the percent of my total hours, because this is my total, come from my full-time job, because that's my full-time job up there. So again, using a calculator, this is the piece we want to know, so we'll call this X. We can do this division, and then I could multiply by 100, because that would get rid of this divide by 100. I can multiply this answer by 100, and that will calculate what percent I need. That'll get me X equals. And I end up with 77.55. If you want to round to just one decimal place, 77.6% would be appropriate. So 77.6% of the total hours that I work were at my full-time job. Number 13, to solve this, again, just pretty straightforward what we've done before. The first step is always to simplify each side, and that includes distributive property, in this case, distribute subtraction. It says 9 minus this quantity. So 9 minus all of that means we're going to subtract 6, and we're going to subtract a minus 2n. So that means 2n is going to be added. Same kind of thing over here. It says 7n take away 3 times this. So we need to take away 3 groups of all of that. I'm going to take away 3 groups of n, so minus 3n. And I'm going to take away 3 groups of minus 5, so that becomes plus 15. Now I'm not done simplifying until I've combined like terms. So on this side, I have a 9 minus 6, which is 3, plus 2n. And on the other side, I have a 7n minus 3n, so that's 4n plus 15. Now that we've completely simplified both sides, now we can get all the variables to one side. So I'm going to subtract 2n from each side, and that will get rid of them from the left-hand side. It'll leave me with 3 equals 2n plus 15. Then I'm going to get all my constants to the other side. So sitting here with 3 equals 2n plus 15, I don't want the constants on the same side as the variables, so I'm going to get rid of this 15. I'm going to add its opposite. So all I'm left with over here is 2n, and on the other side, I've got negative 12. And then finally, I want to get 1n. I want to get that coefficient to equal 1. So I divide by the coefficient 2 and get that n equals negative 6. And again, to know if this is right, I can go back to the original problem and I can check it. If I put negative 6 into the equation everywhere I saw n, and I use my order of operations to check this, I'm going to get on the left-hand side 9 minus 6 minus negative 12, so 6 plus 12, or in other words, 9 minus 18, which is negative 9. And on the right-hand side, I'm going to have 7 times 6, which is negative 42, minus 3 times, and then in here, negative 6 minus 5 would be negative 11. So this is negative 42 plus 33, and the difference between those two is negative 9. And so the two sides are equal, so I know I'm right. Okay, last two. We'll actually jump to 15. It's a little bit easier than 14. We want to figure out the sales tax on this dinner. And so we need to know what is 5.25% of 5220. So like before, I'm going to actually use the equation method. I'm going to take 5.25 out of 100, or move the decimal left 2. And I'm going to take that times the whole amount, which is the total amount of the bill. And what I will get then is the part, which is the amount of the tax. Same kind of thing down here. I'm going to take 15% divided by 100, so that would just get me 0.15. And take that times the whole amount, which is again 5220. And that will give me the part, which is the tip. Once I've calculated both those amounts, then all I have to do is add the bill, 5220, with the tip and the tax. So I'm going to go ahead and do those calculations. Okay, notice when I do this first one here, I actually end up with a number that goes beyond the way we normally write money. Money is only 2 decimal places out to the nearest hundredth. So I'm going to have to round, and because the amount after this point is smaller than 5, I know that this rounds down to 2.74. So this would be 2.74. Remember, this is money, so make sure you put a dollar sign on it. This part right here is exactly 7.83. And when I add those two amounts together, along with the total bill that the dinner cost, I get $62.77. That's the total amount that I will end up paying if I paid that exact amount of tip. Typically, if my tip was this, I'd round it up to 8. All right, the hardest one of the entire worksheet is this one, where we're trying to figure out the original price. And we know it's on sale for 65% off. Now, if I set up a proportion like this and say 65% of the original price, what it's going to find for me is the amount that I saved, the dollars that was taken off. Or if I set it up as a proportion, it would say 65 over 100 equals the dollars off the price compared to the original price. Well, I don't know the original price, and I don't know the dollars that were taken off. So this proportion is not going to help me at all. What I need is a proportion that looks at the dollars that I paid, because this is what I paid. So if I had 65% off, that means that I'm actually paying 35% of the price. So what I want is a proportion that says 35% of the price, of the original price, is going to be $5.83. By looking at it this way, now I can actually determine, because the only thing I don't know is the original, I can actually go through and determine that original price by taking 5.83, multiplying by 100, and then dividing by 35. And I end up with $16.66 when I round it. If I want to know if this is correct, and you're really comfortable with doing it the other way, what you could do at this point now is you could go through and you could find 65% of 1666. Figure out how many dollars you saved and subtract it, and you should end up with the 583. You cannot say that this is 65% or yeah, you can't say that this is 65% and add it back on, and you can't find 65% of this and add it back on. The only way to do this problem is the way that we have set up here, either in proportion form or in equation form. All right, good luck on your test.